November 12, 1942, Richmond, California. A whole cargo ship, 441 feet long, was ready to enter San Francisco Bay from the Permanente Metals Corporation shipyard. This ship had been put together in only 4 days, 15 hours, and 29 minutes. For centuries, skilled builders had spent 6 to 8 months making ships of this size. But here, a finished Liberty ship was ready to sail. Over 1,000 workers stepped back from the hull of the SS Robert E. Peary. They were not traditional shipbuilders. They were former office workers, farmers, homemakers, and laborers who had learned to weld just weeks earlier. The crowd of officials, reporters, and other shipyard owners had come to see a moment that would change manufacturing forever. A revolution in American production that would be felt for years to come. The numbers that would ensure Allied victory were being written not in battle plans, but in production counts that broke every rule experts thought they knew about shipbuilding. The change started on December 27, 1940, when Henry J. Kaiser signed his first shipbuilding contract. He was a man who had never built a ship, never run a shipyard, and had spent his career on huge construction projects like dams in the American West. Yet this 58-year-old builder promised the United States Maritime Commission he would build 30 cargo ships for the British government in 2 years. Experienced shipbuilders saw him as a foolish newcomer. The Todd Bath Iron Works, a very old American shipyard, agreed to work with Kaiser, thinking their knowledge would make up for his lack of it. What they did not realize was that Kaiser's ignorance of shipbuilding was his biggest strength. Among those watching was William Francis Gibbs, America's top naval architect. His company had drawn the plans for the Liberty ship based on British designs. He had designed more ships than Kaiser had probably ever seen. The move from doubt to revolution began in the planning offices in New York. As Kaiser and his team looked at how ships were usually built in early 1941, they saw right away that the old ways would never meet the needs of war. Kaiser's lead engineer, Clay Bedford, had recently visited a Ford car factory. He saw car frames moving along a line, while workers added pre-made parts at each station. He returned to California sure that ships could be built the same way. Traditional shipbuilders thought this idea was ridiculous. The first big surprise was Kaiser's plan to stop using rivets completely. Old-style shipbuilding used rivets, which are hot metal pins hammered through steel plates to join them. A good crew could put in about 100 rivets a day. One Liberty ship needed about 1 million rivets if built the normal way. Kaiser wanted to use electric arc welding instead, a method he knew from building pipelines across the West. Vice Admiral Emory Land, head of the United States Maritime Commission, looked at Kaiser's plan with great doubt. His private letters show what the shipbuilding experts thought. Welding is not proven for building holes this big. The British Navy does not allow it for warships. Kaiser wants to risk America's supply lines on a method we cannot trust. But Land also saw how desperate things were. German submarines and raiders were sinking Allied ships faster than regular shipyards could replace them. In 1941 alone, about 3.6 million tons of Allied ships would be sent to the bottom of the sea. Britain was running out of food. American shipyards using old methods needed about 230 days to build one cargo ship. At that speed, the Allies would lose the Battle of the Atlantic before America could help. The decision to approve Kaiser's contract came not from confidence, but from need. The Richmond shipyard was built on empty mudflats between January and December 1941. Kaiser's construction crews, used to building dams and roads, put up a facility that shocked traditional marine engineers. Instead of the big cranes and long building docks of normal shipyards, Richmond had something completely different. The yard was set up like a car assembly plant. Open spaces for building sections in advance surrounded 7 parallel building docks. Train tracks ran through the facility to move huge steel parts weighing up to 150 tons. Big cranes that could lift whole ship sections stood every 100 feet. John Riley, the head naval architect for Bethlehem Steel, with 30 years of experience, visited the Richmond yard in May 1941. His secret report was critical, but also showed a little admiration. Kaiser has broken every rule I learned about how to set up a shipyard. His pre-building areas are too big. He has too many cranes. His building docks are too short. But I have to admit, the place is designed for exactly what he says, putting together pre-made sections very fast. The workers brought the next big change. Normal shipyards hired from families where skills were passed down from father to son. Kaiser put ads in newspapers all over America, offering pay 20% higher than normal and promising to train anyone who wanted to work. The first workers came to Richmond in August 1941, breaking down difficult jobs into simple, repeated tasks, taken from factory assembly lines, worked incredibly well. By October 1941, Kaiser had over 10,000 workers in Richmond, and fewer than 200 had ever worked on a ship before. Traditional welders spent 4 years as apprentices learning all the skills. Kaiser's teachers showed people specific methods for specific jobs in about 2 weeks. Workers did not need to know how to weld everything, just how to weld the straight seams on walls, or the flat deck plates, or the curved hull sections, which they would do over and over. As workers got better through late 1941 and early 1942, something amazing happened. The time it took to build a Liberty ship started dropping fast. Kaiser's first Liberty ship took 197 days, the second one took 169 days, the fifth took 128 days, the 10th took 97 days. By the spring of 1942, Richmond was finishing Liberty ships in 70 days on average. Traditional shipyards watched with worry as this untrained team built ships as fast as their own highly skilled crews. The pre-building method that traditional builders had made fun of now showed its power. Instead of building a ship from the bottom up in order, Kaiser's yards built whole sections at the same time in different parts of the facility. While one team put together a front section in the pre-building area, other teams built back sections, deck houses, engine rooms, and walls at the same time. When the sections were done, huge cranes lifted them onto the building docks where welding crews joined them together. Albert Wooding, a production boss at Richmond, explained the efficiency in a 1943 magazine interview. In normal shipbuilding, you cannot put the engine in until the engine room is built. You cannot build the engine room until the hull is done. Everything happens in a line. Kaiser's way lets things happen at the same time. While one crew welds hull plates, another crew builds the engine in a different area. When both are ready, we lowered the finished engine into the finished engine room and weld it shut. Jobs that used to need weeks now take hours. The numbers behind this parallel production showed a manufacturing efficiency that seemed impossible to traditional builders. A normal shipyard might have 50 workers trying to install an engine over 3 weeks, working in a tight, partly built engine room. Kaiser's pre-building method put 200 workers to build the whole engine and its frame in an open workshop over 5 days, then used cranes to put the whole thing in place in one 8-hour job. Even more upsetting to the traditional shipbuilding leaders was how casually Kaiser got rid of practices that were hundreds of years old. Ships had always been built from very detailed plans that showed every single part. Kaiser used simpler drawings that gave basic sizes and let workers figure out the details. Traditional builders thought this was dangerous. Kaiser called it being flexible. Vice Admiral Howard Vickery of the Maritime Commission, a career Navy man, first fought against Kaiser's simple plans. His change from doubter to supporter, written down in meeting notes, showed how results can beat theory. In January 1942, I was against Kaiser's request to use fewer drawing details. Ships are not cars. Shipbuilding needs precision. But by March, Kaiser's yards were building 40% more ships than our traditional builders. By June, it was 70% more. I learned that wanting everything perfect can stop you from having something that is good enough. Kaiser's ships were not pretty. They were good enough, and a good enough ship that is delivered carries more cargo than a perfect ship that is still being built. As building speeds got faster through the spring and summer of 1942, a competition started between Kaiser's 7 shipyards in California, Oregon, and Washington. His son Edgar, who was vice president and managed all the shipyards, focused on the 3 in the Pacific Northwest. Clay Bedford ran the Richmond yards in California. The 2 men, both driven and ambitious, started an informal race to see whose yard could build ships faster. The contest between Richmond and Portland became a public show in the fall of 1942. Newspapers gave updates like sports scores. Records kept getting broken until the Oregon shipyard built the Joseph N. Teal. In just 10 days, in September 1942, Vice Admiral Vickery finally told them to stop the speed races, calling them stunt shows that took attention away from real production goals. But the competition had done what Kaiser wanted. Workers in all 7 yards now believed that amazing speed was not just possible, but expected. November 1942 brought the greatest show of all. Vice Admiral Land was visiting Richmond to check on production. He made a casual comment to reporters that was heard by Clay Bedford. The Admiral said that Liberty Shipbuilding had gotten much better, but noted that the recent speed record still seemed slow compared to what mass production had done in other industries. Bedford took the comment as a challenge. He told Vice Admiral Land that Richmond Yard No. 2 would try to build a whole Liberty ship from the first piece to launch in under 10 days, cutting the Joseph N. Teal's record in half. Land, doubtful but interested, allowed the try as long as it did not mess up the normal production schedule. Bedford picked the 47th hull to be built at Yard No. 2 for the record attempt. The ship would be named the SS Robert E. Peary after the Arctic explorer, starting on Sunday, November 8th, just after midnight. Over 1,000 workers on carefully planned shifts would try something never done before in the history of ships. The pre-building strategy was used to its fullest during this construction. Every major part had been built, checked, and placed in position before the first keel piece touched the building dock. The front section, made of more than 50 separate pieces, had been fully welded and fitted with anchor gear, chain lockers, and crew rooms before the main building even started. The back section included the finished steering equipment, propeller shaft, and rear crew spaces. 4 complete cargo holds, each one a giant box of steel ready to be lifted into place. The engine, a 140-ton steam engine built by the Joshua Hendy Iron Works, had been mounted on its base and tested before it even left the factory. Where normal shipyards built from the bottom up, over months, Kaiser's yards put together a nearly finished ship from pre-built sections in days. 4 days into the building, the hull was done. Engine in deckhouses on, cargo hold secured, steering gear mounted. On Thursday, November 12th, at 3:30 in the afternoon, only 4 days, 15 hours, and 29 minutes after the first keel piece was laid, the SS Robert E. Peary moved down the rails into San Francisco Bay. The ship was ready for service on November 15th, setting another record of 7 days, 14 hours, and 32 minutes from the first piece to full delivery. The crowd of watchers included shipbuilding officials, military officers, competing shipyard owners, and reporters from across America. Many came expecting to see a failure or a ship that looked done but was not really usable. What they saw instead was a fully working ship that needed only small final touches before it could sail. Vice Admiral Land, who was there for the launch, made a short speech that was filmed. His words showed that the shipbuilding experts had to admit that everything was different now. 6 months ago, I would have said this could not be done. Traditional shipbuilding knowledge, gathered over 3,000 years, said you cannot build a proper ship in 5 days. Henry Kaiser has made that old knowledge out of date. The United States Maritime Commission will now require all the shipyards it works with to use these methods. The effect on traditional shipbuilders was deep and immediate. The same yards that had laughed at Kaiser as a know-nothing outsider just 18 months earlier now sent their engineers to study his ways. The president of New York Shipbuilding Corporation, one of America's oldest and most respected yards, visited Richmond in December 1942. His secret report to his bosses showed a complete change of mind about the old methods. Kaiser has done what our industry thought was impossible because he refused to accept our limits. He saw shipbuilding as a manufacturing problem, not a craft handed down through generations. He made things simple where we tried to make them perfect. He made things standard where we made them custom. He trained large numbers of unskilled workers where we developed experts over generations. The result is ships built in 1/10 the time at 2/3 the cost. We must use his ways or become unimportant. By early 1943, Kaiser's influence had changed American ship production. 18 shipyards across the country were building Liberty ships using pre-building and welding. The average building time had fallen from 230 days at the start to just 42 days by the middle of 1943. The United States was launching 3 Liberty ships every day, creating more ship space than German submarines could destroy. But maybe the most powerful challenge to the old shipbuilding authorities came from the people Kaiser hired. The tens of thousands of women, minorities, and untrained workers who had built these ships went against the old guild system that had controlled shipbuilding for centuries. At the peak of production in 1944, Kaiser's 7 yards employed about 196,000 workers. Of these, over 40,000 were women, a very high number for that time. By the middle of 1944, women made up 27% of the workers in Richmond. The three Northwest Kaiser yards alone hired over 31,000 women by 1944. African American workers numbered in the tens of thousands, working in skilled jobs like welding, fitting, crane operation, and even as bosses. This level of workplace mixing was unusual for America in the 1940s. The opening up of skilled work that Kaiser made possible had effects that went far beyond wartime production. By showing that complex manufacturing could be done by trained workers instead of needing generations of craft knowledge, Kaiser's shipyards challenged basic ideas about labor, skill, and how industry should be organized. Christmas 1943 showed another example of Kaiser's new industrial culture. While traditional shipyards closed for a day or two for the holiday, Kaiser's yards kept working. But instead of just making people work, Kaiser's company held Christmas parties that recognized the workers' hard work. At the Richmond yards, the managers arranged for a full Christmas dinner to be served in the cafeterias, with turkey, ham, and all the usual food given for free to workers on their shifts. Local churches sent singers. The Richmond Town Band played. Kaiser himself visited the yards, shaking hands with workers and thanking them personally for their service. By the middle of 1944, Kaiser's 7 shipyards had made over 800 Liberty ships, but the effect of his methods went much further than his own yards. The 18 American shipyards building Liberty ships had together made 2,400 vessels by this point. Victory ships, a bigger and faster design that joined the Liberty ships from 1944 on, were built using the same pre-building and welding techniques. The total American ship production between 1941 and 1945 was more than 5,500 vessels, about 53 million tons of shipping. The size of this production was stunning to people at the time and is still impressive today. Commander Joseph Kenworthy of the British Royal Navy, who was assigned to the British Admiralty Office in Washington, watched American production with a mix of respect and jealousy. His official reports to the Admiralty, made public years later, showed the British view of American industrial power. The United States is building merchant ships faster than the rest of the world put together. Kaiser alone makes more ship tonnage each month than the whole British shipbuilding industry. The methods are rough by Admiralty standards. The ships are not elegant, but they float. They carry cargo, and there are thousands of them. The Royal Navy built the best warships in the world, using old-fashioned craftsmanship that took years for each ship. The Americans build good enough ships in weeks. Good enough, when you have thousands, beats perfect, when you have only dozens. But maybe the most amazing part of Kaiser's change was what happened after the war ended. Experts thought the wartime shipbuilding boom would collapse, leaving thousands without jobs and many expensive shipyards empty. Yet the knowledge gained during the emergency program did not disappear. The pre-building techniques, welding methods, and assembly at the same time approaches that Kaiser started became normal practice in shipbuilding around the world. When Japan and South Korea rebuilt their shipbuilding industries in the 1950s and 1960s, they studied Kaiser's Liberty ship program and used his methods as the basis for their own yards. The huge shipbuilding places in Ulsan, South Korea, and Nagasaki, Japan, that would lead world ship construction for decades, were direct children of the revolutionary practices at the Richmond shipyard. John Bunker, a professor of maritime history, summed up Kaiser's lasting influence in a 1972 study. Kaiser came to shipbuilding as an outsider. He did not know maritime traditions, was not held back by common beliefs, and was willing to use manufacturing ideas that the established industry thought were wrong for building ships. In 36 months, he built more ships than had been made in America during the entire previous 100 years. More importantly, he changed how ships would be built everywhere for the rest of the 20th century. The building in modules, pre-building, and welded assembly that Kaiser started are now used by everyone. Every modern shipyard, whether it builds container ships in Korea, oil tankers in Japan, or cruise ships in Europe, uses methods that came from Kaiser's Liberty ship program. The size of Kaiser's achievement can be seen in numbers that show both the huge scale of the program and its amazing success. Production numbers show 2,710 Liberty ships built across 18 American yards between 1941 and 1945. At the peak, that was an average of 1.8 ships every day. Kaiser's 7 yards alone built 1,490 ships, which was 27% of all American merchant shipping built for the war. Building time fell from an average of 230 days for the first Liberty ships in 1941 to 42 days by 1943. The record holder, the Robert E. Peary, needed only 4 days and 15 hours from the first keelpiece to launch. Workers became much more efficient as they gained experience. The first Liberty ships needed about 1.1 million worker hours to finish. By 1943, the average had fallen to about 486,000 hours per ship. Kaiser's best yards, Richmond numbers 2 and 3, got it down to as few as 350,000 worker hours by using 3 shifts, working 24 hours a day, and making the most of pre-building. Costs also got better. The first Liberty ships cost about $1.75 to $2 million each. By 1943, costs were down to $1.8 million, even though wages and material prices were going up, showing that efficiency was improving. Each Liberty ship could carry 10,800 tons of cargo. The ships could transport 2,840 jeeps, 440 tanks, or 230 million bullets in one trip. Powered by old-fashioned but reliable and easy-to-make steam engines, the ships could go 11 miles per hour, which was fine for traveling in groups. Training was also very efficient. Kaiser's schools trained workers for specific jobs in about 2 weeks on average. The fastest training made useful spot welders in just 10 days. More complex jobs, like crane operator, took 4 to 6 weeks of training. This was very different from traditional shipbuilding apprenticeships, which lasted for years for basic skill and 10 years to become a master. The key difference was that Kaiser's workers learned one specific job they would repeat hundreds of times, while traditional apprentices learned every part of shipbuilding. The number of Liberty ships lost in battle showed they worked well, even though people doubted the fast construction. Of the 2,710 Liberty ships built, about 200 were lost to enemy action, a loss rate of 7.4%. This was better than peacetime merchant ship loss rates, and proved that welded ships, though people were suspicious at first, were strong and seaworthy. A few ships had structural problems because of welding issues. 3 Liberty ships broke completely in half because of brittle fractures, which was 0.11% of all ships built. Nearly 1,500 cases of significant brittle fractures happened across the Liberty fleet, but complete breaks were rare. These problems led to better welding methods and steel mixers that fixed the issue by 1944. How long the ships lasted was the final proof that Kaiser's methods worked. Liberty ships were designed as emergency vessels, expected to last 5 years, but many served for decades after the war. The SS John W. Brown, built in 1942, is still operating as a museum ship in Baltimore today, 82 years after it was made. The SS Jeremiah O'Brien, also built in 1942, is kept in San Francisco and sailed to Normandy under its own power in 1994 for the 50th anniversary of D-Day, 50 years after it was built. A third Liberty ship, the SS Hellas Liberty, is a museum ship in Greece. The careers of Liberty ships after the war went far beyond their planned life. Of the about 2,510 Liberty ships that survived the war, roughly 835 were still in commercial use through the 1960s. Many were sold to foreign shipping companies and operated into the 1970s. The SS Albert M. Bow, the last Liberty ship delivered on October 30, 1945, was not taken apart. Sold in 1964, it became a fish canning ship called the Star of Kodiak in 1965. Today, it is the land-based office of Trident Seafoods in Kodiak, Alaska, and still exists 8 decades after it was built. The economic effect of the Liberty ship program spread through American industry. The huge need for steel led to more steel production, especially on the West Coast, where Kaiser built the Fontana steel mill just to supply his shipyards. This mill, finished in 1942, made about 700,000 tons of steel a year and made California a major steel-producing area for the first time. The magnesium needed for bombs and the aluminum for planes were made in Kaiser plants, built to support the whole war production effort. The effect on jobs spread through towns in California, Oregon, and Washington. The city of Richmond, California, grew from 23,000 people in 1942 over 100,000 by 1943, all because of the shipyards. Kaiser built Vanport City in Oregon, which quickly became the state's second-largest city, with over 40,000 people, all of whom worked in the shipyards or in jobs that supported them. These boom towns, though they did not last, showed how powerful concentrated industrial investment could be. Healthcare innovation became an unexpected result of Kaiser's shipbuilding program. To provide medical care for his huge workforce, Kaiser worked with a doctor named Sidney Garfield to set up prepaid healthcare. This later grew into Kaiser Permanente, one of America's biggest health maintenance organizations. The model of prepaid preventive healthcare that started in the shipyards affected American medicine for decades and served over 12 million people by the early 2000s. The workers themselves carried the lessons from the wartime experience into years of peace. The shipyards gave thousands of young people, especially women and minorities, chances to learn skills they would never have had through normal career paths. These opportunities opened doors for the rest of their lives. The technology advances from the Liberty Ship program affected industries far beyond shipbuilding. The welding methods improved under wartime pressure became standard for building steel structures, making oil refinery equipment, and constructing pressure vessels. The pre-building ideas started at Richmond, changed how people built houses, bridges, and industrial plants. The organizational ideas of parallel production, simple plans, and fast worker training became basic concepts in business management and industrial engineering education. A professor at Harvard Business School, looking at American industrial power in a 1985 study, called the Liberty Ship program a key example of building ability quickly. Kaiser showed that industrial power is not fixed but can be created very fast when needed. The United States started World War II with very little ability to build merchant ships. Within 24 months, American yards were making more ship tonnage than the rest of the world combined. This proved that industrial buildings, worker skills, and production systems could all be developed at unheard of speed if they were organized well. This lesson matters outside of wartime emergencies. It suggests that what we see as limits on industrial power are often really limits of organization and imagination, not true physical limits. The change in thinking that the Liberty Ship program caused among factory managers and engineers was as important as the ships themselves. Before Kaiser, production bosses accepted common beliefs about production limits, skill requirements, and how to organize. Kaiser showed that common beliefs could be wrong, and that to make huge improvements, you had to question basic assumptions. The story of the Liberty Ship is finally about a deep truth of what people can do and what industry can achieve. The ships themselves, though vital to Allied victory, were less important than what building them proved. Ordinary people, given training and a chance, could do amazing things. Complex products that once took years of craft skill could be made in weeks, using organized systems. Industries that had resisted change for hundreds of years could be completely transformed in months when need and new ideas came together. Admiral Chester Nimitz, who commanded the Pacific Fleet, thought about the strategic effect of American ship production in his memoir after the war. We fought across 5,000 miles of the Pacific Ocean, supplied by ships that were built faster than the enemy could sink them. Japan's military planners thought American industrial power was great but had a limit. They believed if they sank enough ships, American supply lines would fall apart and we would have to talk peace. They did not account for Henry Kaiser. By 1944, we were replacing lost ships faster than Japan could sink them. The numbers of loss favored the side that could build 3 ships a day over the side that could sink 2. Industrial power, not battlefield courage, decided the result. The Pacific War was won in the shipyards of Richmond, Portland, and Baltimore, as much as on the beaches of Iwo Jima and Okinawa. In the end, Kaiser's greatest achievement was not the 1,490 ships his yards built, but the change in what industries believed was possible. The Robert E. Peary, built in less than 5 days, was real proof that tradition was not always right, that common beliefs could be questioned, and that to make a huge leap forward, you needed a completely new approach. The shipbuilding experts who laughed at Kaiser as an ignorant outsider in 1940 spent the years after 1945 studying and using his techniques. The young workers who learned to weld and fit and build carried those skills and that confidence into peaceful jobs that helped build America's economy after the war. The methods started during a wartime emergency became peacetime standards that changed manufacturing in all kinds of industries all over the world. The story of how one civilian-esque approach made Liberty ships appear in days instead of months is finally a story of change through proof. It shows that the biggest revolutions often come from people who are not limited by tradition, that progress requires questioning accepted limits, and that people can do more than anyone thinks when they are organized well and given a challenge. Kaiser's workers were not superhuman. They were ordinary people doing extraordinary things because someone believed they could and set up systems that let them prove it. This lesson, shown in the shipyards of Richmond and proven true by 2,710 finished ships, still matters wherever industries face challenges that common wisdom says cannot be beaten. The Liberty ships are mostly gone now, taken apart long ago, or resting on the ocean floor. But the revolution they represented lives on in every modern shipyard, in every factory that uses pre-building, in every training program that teaches specific skills quickly instead of broad knowledge slowly, and in every manager who wonders if impossible really means impossible or just means no one has figured out how to do it yet. That is Henry Kaiser's lasting legacy, written not in steel, but in a changed understanding of what committed people can do when they are freed from the limits of tradition and challenged to try what the experts say cannot be done.